All right, it's 10 o'clock somewhere, and it's afternoon somewhere, and the evening somewhere, and morning somewhere. So welcome, everyone. So this is C11 Custom Neural Machine Translation with two partners, Paula Reichenberg with Ruben Martinez Dominguez and with Marcis Pinnis, and Laura Daly from Vistec here moderating, and Dmitriy Genzel will be joining us shortly to help out, and we have Janice as always. Thank you to the commercial track chairs, Janice and Dmitriy, and then of course our sponsors, Facebook, Microsoft, Amazon, and Adobe. And don't forget to go check out your sponsors and all the different people that are exhibiting. Go hang out at the different channels, right, Janice? And let me introduce our presenters today. So we have Paula Reichenberg from Hieronymus. Paula is the CEO of Hieronymus, and Hieronymus is all about translations by lawyers for lawyers. It's a Swiss boutique LSP specializing in legal and financial translations. And together with Tilde, Paula conceived of and developed Lex Machina, the first neural machine translation platform for Swiss lawyers. And then Ruben is the international client expert at Tilde, where he helps clients to overcome language barriers, automate their processes, and conquer new markets with the latest language technology. And as a visionary, Ruben has developed clients across the globe to implement machine translation solutions to streamline operations and improve communication. And you're joined with Marcis Pinnis, who is the Chief AI Officer at Tilde. Marcis, you're an AI-powered technology expert, and your current research is in neural machine translation, including hybrid methods for neural machine translation, terminology integration, domain adaptation strategies of neural machine translation systems, etc. And while at Tilde, Marcis, you've been involved in many EU-funded projects, as well as several nationally funded projects in Latvia, Lithuania, and Estonia. Looking forward to hearing you guys talk about custom neural machine translation projects that you did together. I think you can start to share. Let's see. And as usual, everyone can please put your questions in the chat, and we will.
Great. Thanks, Lara, for the introduction. Just to confirm that everyone sees the screen right now that we are sharing.
Yep.
So as Lara just introduced, we will talk over the last few minutes about this case, custom neural machine translation systems for the Swiss legal domain. Just a quick overview. We will talk briefly about Tilde and Hieronymus. We'll present the requirements of the case, the development of a Lex Machina platform. We will give insights on the development of machine translation systems, and of course, we'll go through the details of the deployment. So briefly about Tilde. We are a company that has been in the market for almost 30 years. Actually, next year, we'll celebrate our 30th anniversary. And we are a strong and very focused language technology research and development company. We have a strong focus on artificial intelligence language solutions. And within this area, we develop custom machine translation systems for both the public sector, with some examples here on the screen, and also for the private sector, with both on-premise or on-cloud solutions adapted to our partners.
Yes, so at Hieronymus, before NMT came along, we were doing pretty well. Being a traditional boutique LSP for a very specific market, the Swiss and legal financial industry. And our unique selling points were a team of in-house lawyer linguists and proprietary specialized know-how. So we were faced with this question, what do we do now? And instead of facing a slow and miserable decline, we decided to fully embrace NMT. And we saw a bunch of opportunities. if we could be fast enough to take over the Swiss legal translation market, something that we could do maybe more easily than others, being relatively small and very agile, of course. By leveraging our unique selling, our specialized know-how and our specialized human capital, we could disrupt the classic LSP business model and offer Swiss lawyers direct access to what we hoped would be the best Swiss legal NMT engine in the world. So to roll out this ambitious plan, we just needed to find the right NMT partners. Our requirements were very particular. We had security needs because Swiss lawyers are subject to very strict regulations. And so that was a first point that made us consider Tilde because of their experience with a lot of different governments and extremely sensitive data. Then as well, we were actually working with low resource languages, more or less, because Swiss German, Swiss French, and Swiss Italian are not as common as you would think. Another point that spoke for Tilde and their experience with low resource languages. And finally, of all the NMT partners we talked to, they were the only ones who really agreed with us on the fact that it would be a bad idea to mix up all Swiss legal data by creating just one engine, and that really suggested taking a differentiated approach to the data of the specific subdomains. So yeah, that's how we selected our partner.
So then, based on these opportunities, these requirements, what we did was a proposed solution, and this is called Lex Machina, full set of adapted neural machine translation systems, which are integrated into an also customized translation platform. Lex Machina offers full translation of text snippets, documents, maintaining also the formatting, which is something very important, translation of websites, and of course also CAT tool integration via plugins. And of course, as we just discussed, it's also operated in a secure Switzerland-based infrastructure.
So in the next couple of minutes, I will tell you a bit more about how we developed all the machine translation systems for Lex Machina. So a typical machine translation development effort consists of data collection, data pre-processing, neural machine translation system training, and evaluation. I'll start by talking about data collection. So what makes this particular use case different from others is that we had to develop machine translation systems for not the standard German, Italian, and French languages, but rather Swiss dialects of French, Italian, and German. But the majority of parallel data that is available publicly and also proprietary is in standard French, Italian, and German. However, whenever we train machine translation systems and neural machine translation systems, we have the possibility to pre-train an engine using general language and then fine-tune it for particular domains or particular dialects. So we took this approach, the fine-tuning approach, and collected all the data that we could acquire. So that means three types of different. One is publicly available parallel corpora, which is in the standard French, Italian, and German, not necessarily from Swiss origin. However, it's in large quantities, so it can help in pre-training NMT models for French, Italian, and German. And this data is actually already readily available. There were a couple of examples listed before. Some of the largest ones that we used were DGT translation memories, Europarl. We did, of course, focus on more legal oriented texts or formal texts rather than colloquial texts. The second type of data is parallel data from legal domain websites from Switzerland. And that we had to collect through web crawling. And web crawling obviously introduces some noise whenever it's applied. It's not as clean as parallel data from translation memories, which meant that we had to apply stricter filtering for this type of data. However, it's of Swiss origin, and because Switzerland has 4 official languages, it's actually quite widely available. And then the third type of data was translation memories from Hieronymus, which is of smaller quantities. However, it's of Swiss origin and from the precise domain in which we had to train the machine translation systems in. So once we had collected all the data sets, so the 3 types of different data sets, we pre-processed the data. Pre-processing typically means that at first we filter out noise from parallel data, because all data contains noise. Not everything that is parallel is actually parallel. So we discarded all or most of non-parallel sentence pairs, sentences in wrong languages, corrupted data, for instance, data that had issues with encoding, partially translated sentences, and also too long sentences, which are not useful for typical neural machine translation system training. Once that was ready, we continued data preprocessing and applied custom natural language processing workflows that allow us to train machine translation systems which are robust to unknown phenomena. For instance, whenever users translate, they enter all sorts of complex texts. Not whenever we train or develop systems for production use, we have to expect that users won't enter clean, linguistically, and also not necessarily from the same language. For instance, whenever you add some words in brackets, for instance, person names in original writing in a different language, that constitutes a foreign language word in a source language text. And in order for MT systems to be more robust against such types of texts, we typically introduce synthetic data, so generate additional training data that allows us to teach neural machine translation models to be robust whenever they encounter something unknown. Then we pre-process it. Can we go back a bit? So then we process the data so that we reduce sparsity for non-translatable units, for instance, emails, file paths, placeholders. We also normalize content, so punctuation normalization is typically applied, and this allows us to, whenever we develop machine translation systems, to apply on the target side correct punctuation rules. So the punctuation rules between standard French, for instance, differ from French of the Swiss dialect. So so the way how we normalize data allows us to later on, during translation, apply correct punctuation in the target language. Then we also had to deal with the issue that Swiss data is of lower quantities than the standard French, Italian, German data. So in order to counteract and counterbalance this issue, we resampled the training data such that in-domain Swiss data and out-of-domain data that comes from Swiss origin is upsampled. So we upsampled the data so that the Swiss origin data has more effect when we train the baseline system. In terms of neural machine translation model training, we used Marian, the Marian NMT toolkit. We trained transformer-based models, and we used guided alignment. So whenever we train production systems, we use guided alignment in order to support processing of formatting tags, processing of non-translatables, recasing that is source text aware, and also this allows us to do automatic post-editing. For instance, if we integrate bilingual dictionaries of exact match translations of phrases that have to have exact translations in the target language, we can perform automatic post-editing, and because we use guided alignment, this becomes possible. So the way how we trained the systems was that we trained baseline systems using all the data that we had, and then we fine-tuned the systems using Swiss in-domain data with a one-to-one mix with baseline training data. And this allows us to ensure that Swiss language specificities and in-domain terminology and style are obeyed in the machine translation systems. Here you see a comparison of the fine-tuned and in-domain machine translation systems when we compare them to Google Translate. And for each of those machine translation systems, we had in-domain test sets provided by Hieronymus or extracted from the in-domain Swiss dataset, the datasets that we use for training, so held out datasets, and this shows that the quality was superior to the general domain systems provided by Google.
5 minutes time check.
So based on this entire process that Marcis walked everyone through, what we did afterwards is develop an implementation phase project based on the first step, where we develop the initial custom machine translation system just to fully test the capabilities and the output of the system. Based on that, what we did, and after getting the right, let's say, formula, we move forward to the training of the remaining systems. Once those were fully trained and developed, what we did was focus on the development of the Lex Machina platform. And once the entire solution was ready to be deployed, we moved to the fourth step, which was the deployment on a Hieronymus infrastructure. Up until now, since March, when the full implementation took place, Lex Machina has helped to translate 2 million words, or what's the same, 112,000 sentences. If we put this in another context, it's about 13 books of Harry Potter since last March.
So yes, definitely, our new custom NMT engines have already allowed us to increase productivity and efficiency on our traditional business, serving clients as an LSP. But it also allowed us to launch now a couple of weeks ago the first self-service legal machine translation solution for Swiss lawyers. We are having our first customers, and they're excited. And it was really nice to to get to talk to all these security specialists who drilled us with questions to know if the system was secure, and that for now all of them have approved our structure, and so this success story has led even to now to us being more than just customers of Tilde. We have been very enthusiastic and have entered a partnership with them. And we are now going to offer this solution customized for banks, insurance companies, and major advisory and accounting companies in Switzerland, joining our strength on Tilde's and Euronym's side. So it's been a really nice use case for us.
Wonderful. That is so inspiring. Before we get into the questions, Dmitriy will scan all the questions. I have a business question. Did this change your business, Paula, significantly?
Yes. So we're still in the transition phase now. So definitely it has changed our processes for the traditional LSP business for certain types of texts. And it has started now completely this new line of products, which we think is the line of product of the future, being able to empower our customers and to offer them really only the services they need, because that allows them to save costs, to offer new services to their clients. And so we're very excited about that, and so are our first customers.
Very good, exciting. Dmitriy?
Yes, thank you again to the speakers. Let me go through some of the questions that people asked in the chat. First question, are linguists involved in the data preparation and pre-processing?
Yes, definitely. So this is really where our partnership between Tilde and Euronymous and our unique strengths, so our really Swiss lawyers who are also linguists and are behind that and can guide this data gathering and processing path is very important.
Great, thank you. Second question, can you elaborate what upsampling and downsampling is?
So I'll start by explaining why we did this. So I'm not sure whether it was very clear in how I explained it. So the large data sets, the general domain data sets that are available for standard French, German, and Italian, they are not necessarily, well, they contain different type of language, style, etc., which is not what Swiss legal domain is about. And in order to balance this, we upsampled the Swiss data. Upsampling means that we multiply the in-domain data sets when we train the baseline system, so that the in-domain data sets have much higher significance or stress on the neural machine translation model that is being trained. We perform upsampling of the in-domain data, not necessarily downsampling. Well, we did downsample colloquial data from the standard English, German, French, and Italian data sets, but only colloquial data sets. So we did not do that for formal data sets. Typically, we upsample the data so that the in-domain data set has more stress. If the out-of-domain data, which is colloquial, is too large, we downsample it. And downsampling means is that we randomly discard sentences from it. We do not discard, let's say, first X or last X sentences, because we want to have language representation. So we perform all the downsampling randomly, and upsampling this time was performed by multiplying, but typically it can also it means that it can also be a randomized process where we randomly increase the data by selecting examples. So supplementing the training data with the same training data, but in a random fashion.
Okay. Can I ask you another technical question? When you talked about guided translation, what do you mean exactly?
If you know how machine translation systems are, neural machine translation systems are trained, so you show the AMTA model a source sentence, then it tries to produce a target translation, and then you fine tune the parameters if the translation is wrong or off the reference translation. Guided alignment actually allows us to also provide alignment information so that one of the attention heads of the transformer model has to produce alignment information that we provided through with the source sentence. So the guided alignment data, so the alignments, source to target alignments, are typically extracted using statistical alignment models. So for instance, using FastAlign or Giza++ or alternative ones. In our case, we used FastAlign.
Great, thank you very much. Next question is, the Google system that you compare it to, was it a generic engine or was it a system trained in AutoML with the same data?
That's a generic engine.
Okay. Did you use human evaluation or just Blue?
Yes, we didn't elaborate it here, but we performed human evaluation forth and back throughout the whole development cycle. So we also perform comparative human evaluation whenever we have one model and another model, and we have to compare them. We didn't show any comparative results because that's during the development efforts. So whenever we systems in order to see whether a better model is so a new model is better than the previous model, we always perform human evaluation. We do not rely just on the automatic scores.
All right, thank you. Next question is, you mentioned that confidentiality is a requirement. Do you also apply anonymization techniques to the training data?
Not right now on the training data, but the way how we train the systems that are able to process unknown phenomena, the same approach can be applied for anonymization if you replace named entities with placeholders. There's always a loss of information whenever you replace something with a placeholder, but the same mechanism of how we train the systems with synthetic data allows us to actually use this type of mechanism.
And let me just tell you as well that we did not, from our translation memories, all the data that we transferred to Tilde for training were not confidential data. So we have very thorough procedures at Hieronymus. So there was no anonymization needed because the data we provided did not need that.
All right, thank you. Probably the last question we get to is, do you use MT output raw or do you have post-editing?
No, we always have post-editing. So of course, our direct clients, so the lawyers, they can use raw output. But as a traditional LSP service, we would never offer raw data. So this is what the lawyer gets when the lawyer produces this outcome himself. And then, of course, they can use it because it's good enough to discuss a draft with a client, etc. So that's good. But we as Hieronymus would never. We only give our clients fully post-edited, high-quality translations that have also been checked by lawyers. So you can only get raw output if you're a direct client of Lex Machina.
All right. I think we're at time. Thank you very much for all the speakers.
Thank you.
Thank you very much.
Thank you very much, guys.